14.2, choosing among linear, quadratic, and exponential models. How do you choose among linear, quadratic, and exponential models for a given set of data? I'm going to review just a minute what those are because we haven't done linears and quadratics in a while. A linear looks like a straight line. That is linear. It can go up or it can go down. If it goes up, then the A is greater than 1. If it goes down, then A is less than 1. Linear, straight line. Make these into zeros. I didn't think that looked right. A is greater than 0 or A is less than 0. What does a quadratic look like? Quadratic.
Parabola?
It's a parabola. It's a U shape. It's either up or it opens down. Either way, it's a parabola, a U shape, it opens up or down. If the A is greater than 0, it opens up. If A is less than 0, it opens down. Exponential. Hopefully exponential, you know what those are. We've been working on those this whole module. If it goes up like this, it is called an exponential what? Growth. Very good. That's an exponential growth. That means that the B is greater than 1 or 0. B is greater than 0 or 1. 1. Okay? If it comes down like this, it's an exponential what? Decay. B is less than 1. So it's going to be like a fraction. Alright, so if your base is a fraction, then it's a decay. If your base is not a fraction, then it's going to be a growth. Questions on those? Alright, so look at page 797. The first one we're going to look at is just the linear. Okay, we're going to go through each of them individually. We'll start out with linear, then we'll answer questions about quadratics, and then we'll answer questions about exponentials. The first one is linear. So on page 797, there are 4 pictures there. We want to pick the picture that looks like a linear function. Which one of these do you think is the closest to a linear function?
Bottom left.
Bottom left. Okay, so we picked this one right here. So step 1 says, up at the top, it says pick a picture. Choose a set of data. Then explain why we chose that data. So why did you choose that one right there?
A straight line.
Because it looks like a straight line. So that's why we chose. So step 1, we chose years since 1940. 40. Why did we choose that? Because it looks straight.
90.
90?
I was like,
Okay. It looks straight. It makes a straight line more than anything else. So it looks linear. Looks straight. The next question is, what characteristics to expect in a linear equation? So what do you expect from a linear equation? We know if it's linear, then it has to have the same rate of change, slope, right? We know that it has to look straight. We know that it has to either go up or come down. It never curves. So those are things that ask you about a linear equation. All right, step 2. Step 2 says, enter the data for your choice into your graphing calculator into list and perform linear regression. So here's what you're going to do. You're going to go to your calculator and go to Stat Edit, just like we did yesterday. Stat Edit. Now notice in years these go down this way. Don't go across this way. We're going to start out with 0. This is 0. 1990. 1991 is 1, 2, 3, and so forth. So you're going to put in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. List 1, you'll have 0 through 10. List 2. If your numbers are bigger than 1,000, which these are, let's change them to decimals. Otherwise, we're going to have to set our windows so big that it's going to be hard to read on our calculator. So this says what? 3,035. Let's make it 3.035. Okay, this one right here, we would make it 3.399 or whatever it says. Okay, so put those in list 1 and list 2. Once you get them in there, stop.
What was the decimals again?
Just put it after the first number, between the first and second number.
Okay.
I can't hardly read it. When you get them in list 1 and list 2, then stop. Okay, go back to Stat. Move over to Calc. Go down, not to quadratic, not to exponential, but to linear. I think it's number 4. Hit enter. Where it says X list, L1, hit enter. Y list, L2, hit enter. Frequency, whatever, hit enter. Now, stop right there. We're on the part that says store regression EQ, right? Hit bars, over to Y bars, hit enter twice. Then it should pop up Y1 on your store. Hit enter on calculate. Right there is your equation. It should say we're putting it in y equals ax plus b. What is your a? 0.33x plus your b is 3.04. Okay, so it asks you to write an equation on step 2. Then it says, give the model, we just did, that's the equation, define your variables. What that means is, I'm going to say over here that x equals, whatever that says right there, years since 1990. What does y stand for? Whatever this says right here, bald eagle something pairs. I don't know. Bald eagle pairs. that's what our variables stand for. Then the question says, what are the initial value and the rate of change? So on your linears, our initial value is where it starts right there. Well, that number right there is the 3.04. So it asks us, what is our initial value? We would write initial value is 3.04. And what is the rate of change? Initial value, write it down, is 3.04. And what is my rate of change? What does rate of change mean?
Slope.
Slope. What is my slope? The number in front of x. What is the number in front of x? 0.33. So that's question 2. Question 3, step 3, graph the model along with the scatter plot using your calculator. So right now, hit graph because your equation's in there. Did you get the points and the line? Okay, you should have got points and line. If you didn't get the points, then go second, stat plot, which is right above it. Make sure it's turned on, and it is. On or off. Your windows are messed up.
I think I got the wrong equation too.
Oh,
So that's probably 8.
probably won't work. Yeah, you have to have the right equation. Okay? So, based on the information on your line and your dots, how accurate is it? Does it go through most of those dots? Yes. So, on step 3, it asks you, how well does it appear to fit the data? Then I would put it's really a good fit, or it's a strong line of fit, or something like that. Okay? Questions on that? Anybody? Okay, now we're going to go to page model with a quadratic function. It's on page 801. We're going to answer those questions, but we're still going to be looking at this same picture that's on page 797. So we're still looking at the picture on 797. We're not looking for linear this time, we're looking for quadratic. So which picture do you think has a curve? It has either a maximum point, a high point, or a low point. Which one would you think is quadratic?
First one.
Okay, could be the first, but this one never curves back up. See, it would have to curve up, come down and then go back up. So that one's not quadratic. What about this one? Comes down, goes up. Okay, so let's look at that one right there. So step 1, we picked quadratic. Why did we pick quadratic? What does a quadratic do? Goes down and comes up, or up and down. So what does it do? It changes direction. So we picked it because it changed direction. What characteristics do you see in a quadratic? It changes direction. It has a minimum or a maximum point. It is U-shaped. It's a parabola. You can write any of that for characteristics of quadratic. Step 2. Put the points into your calculator. So I'm going to go back to Stat Edit. I'm only going to put in my list 1 the numbers that are used here. So 0 is used, 2 is used, 4 is used,